Jacob Johnson back here with another GTCS video. Today we're going to be continuing our exploration of file I/O by looking at CSV files. But before we get started, be sure to subscribe and check out all the other content on the channel. With that being said, let's go ahead and hop into CSV files. So first things first, what does CSV stand for? Well, CSV stands for comma separated values, and CSV files generally are used as a way to organize large sets of data. That's kind of a lot of words and description of what a CSV file is, so I figured let's just look at an example. So here I created, for the sake of this video, a very simple CSV file with a little bit of data in it. Let's go ahead and open that up. And the first thing we should notice is that this actually opens up by default in Microsoft Excel on my computer. And so that's an important distinction between .txt and other files we worked with, because those typically don't open up in Microsoft Excel. And so before we really get into the meat of the video, I kind of want to go on a tangent and explain and kind of reiterate the fact that being able to manipulate and work with CSV files in Python is super important, very valuable skill to have to companies, because CSV files are in abundance for a plethora of reasons, but for two in particular that I've encountered in the real world. And that's first because a lot of Microsoft Excel files can be converted to CSV, and therefore you can do a lot of manipulations on Microsoft Excel files, which are obviously in abundance because pretty much each and every company in the world is going to use Microsoft Excel in some capacity. But for another reason, and that's because databases and database tables and rows in databases can often be exported as CSV files, and then in which case you can do analysis and manipulations on data from a database. So those are kind of two examples and reasons that being able to manipulate and work with CSV files in Python is super important. So with that being said, be sure to pay attention a lot and really understand these concepts, because it can come in handy down the road. But let's get with all of that out of the way. Let's actually get into the meat of this problem. And so what I'm going to do is, the first thing we want to do with this file is kind of explore what's going on. So we have three column names here. We have employee name, employee ID, and hours worked, and then we have a bunch of just random data down here. So let's say first you're tasked with identifying the employee who worked the most number of hours in that particular week. So obviously this would be pretty trivial and you could just do this by looking at it, but let's say we wanted to do this via a Python script. So we're going to come back over here, and first things first, just like any other file I/O kind of work we're doing, we're going to open up our file. And so the name of our file was, what was our file's name? Employee data. So we're going to say employee data.csv, and that CSV extension is very important. And as our second argument, we're going to open it up for read mode. An important thing to note here is that we could exclude this read mode, we could exclude this read mode argument, and we actually will, just to remind ourselves that if you don't put a second argument in the open function, that it defaults to opening the file for read mode. So we're going to do that just to remember. And we're going to go ahead and say line list equals my file dot read lines. So we know we have three main methods for files, and that's read, read line, and read lines for the sake of this class. So let's just use dot read lines to kind of see what we're working with. So we're going to go ahead and print out the result of that, and that's going to be stored as line list. So let's go ahead and see what this gives us. So here we can see what we're working with a little bit. The first thing we should note is that the first entry in our list is actually the string containing the column names. So that obviously isn't very useful for us. So we're gonna have a way to get around that and get rid of that. But for now, let's keep looking at our data. The second thing we should know here is that all of our strings, all of our rows of data have a new line character at the end. So immediately in my head, well, excluding the last, which makes sense because that's the last, so it's not going to have a new line character. But all of them except for the last have a new line character. So immediately in my head, alarm bells are going off. We should be thinking about using .strip here to clean up our data. So we're going to go back over here. And so the first problem or issue that we want to kind of clean up a little bit is this column name entry. So the way that we're going to get around this is kind of a nifty and clean way of doing it. What we're going to do is we're just going to simply do read line one time at the very beginning to just skip over that line and then be on the actual line that contains the useful data. So this is simply using .read line because our cursor is starting at the beginning. We're going to read that first line, not even store it as a variable or anything, because for the sake of this problem, we don't care about the column names. And that's just going to move our cursor to be here at England or Lily. So our cursor is going to start there, then it's just going to do read lines from there and give us just our data. So after we've done this change, let's go ahead and look at what we're working with now. And what we can see here is, like I was saying, we get rid of this column name, which is kind of useless and pointless for the sake of this problem. And we just have all of the data that's useful to us. So that's good. That's our first issue resolved. Our second thing we want to do is we actually want to get rid of this new line character at the end of each of the strings. So that way our data is a little bit cleaner and easier to work with. So the first thing we're going to do is we're just going to iterate over this line list. So we're going to say for a list in line list. And we want to change this string. So we're going to say, we're going to change this to aster because we're iterating over strings. And we're going to say aster is going to be equal to, first thing we want to do is strip this, right? So aster is going to equal to aster.strip. So that's going to get rid of this, which is good. And then we're actually going to want to dot split by comma. So this is an important thing to know, and I'll put this at the top as well. A lot of times with CSVs, you're going to be doing dot split with a comma. So just keep that in mind. And what this is going to do is this is going to return us a list, right? Because dot split always returns a list, and it's actually going to use the comma as the delimiter. So if you kind of know what's going on and have a good grasp of Python concept, you should know this really isn't going to do what we expect. Because what we want to do is we want to change this list of strings to be a list containing lists that have each individual entry representing basically a cell in Excel. So we want each individual entry of our list to be, for example, England or Lily, comma 1, 2, 3, 4, comma 15. But what's going to happen here is this actually isn't going to do anything and not be useful to us at all because we're not doing the correct operations, and this is kind of redundant in a way. So let's go ahead and just show that. So like we can see, this didn't do anything to this list. And the reason that is because although we're changing aster to be basically this list because this is going to result in a list, we're not actually changing the value at that index in the list to be reflecting that list that we want it to be. So what we're going to do is we're going to get rid of this, and we're actually going to change what our loop looks like. So we want to have access to our index. So we're going to do for I in range length of line list. So now we have access to our index, so we can change the value at that index. So now we're going to say line list at I equals line list at I. So, and then we're going to use the same formula here. So we're going to strip it to get rid of this new line character. Perfect. Then we're going to split it to create a list that's using our comma as our delimiter. So now, if this worked properly, we should be seeing a list containing sublists that represent each row of data. So let's go ahead and see what we're working with now. So perfect, this worked exactly how it should have. Now we have a list containing individual lists that have the name, comma, the employee ID, comma, the hours worked. In a nice format, no new line characters, none of that weird stuff. So now we actually have that's something that we can work with very comfortably. So now that we have this, we can kind of start attacking the problem. So what we want to do is figure out who has worked the most hours this week. So now that we have this kind of pretty list, we can say for a list in line list. And now we're going to have each individual list, and we want to look at this second index 0, 1, 2. And so what we're going to do up here is we're going to keep track of a winner variable and a winner name variable. And this winner variable is basically just going to be corresponding to the highest number of hours worked at the current point in the iteration. And the winner name is going to be the name of that person who's worked the most number of hours. So we're going to go in here and we're going to say for a list in line list, if a list index at 2, which is the number of hours worked, is greater than winner, then winner equals a list index at 2. Alright, so if you're following along closely and understand what's going on, immediately an alarm bell should be going off in your head saying, this is going to error, this is going to error, this is going to error. And the reason for that is, I'll let you see, but just keep that in mind. So let's go ahead and run this and let's see what happens. Actually, we're going to get rid of this, and just for the sake of acting like this is work, we're going to print winner, comma, winner name. Okay, good. So let's go ahead and run this now. And yeah, just like we'd expect, we're going to get a type error saying this isn't supported between strings and ints. So the reason this happened is the same reason this happens with a lot of times with files, and that is because anytime you read data from a file, it's being read in as a string. So we need to make sure that we're casting or converting what we're gathering straight from our file to be and the actual value we want it to be. So in this case, this was a list. This a list at 2 is a list. I want to convert that to be a float. So just in case it has decimal points, we want to preserve the accuracy of our number. So we need to make sure that we convert these things to float so then we can actually do these comparisons between things. So now this should work like we expect. And here we see that we're printing out winner and winner name. So one more thing in here, made a slight mistake. We want to make sure our winner name gets assigned to the name of the person who had the most hours. So if we go back in here, we can see that our name is always our 0th index, so we can say a list at 0. And that's a string, and that's what we want, so we don't have to do any conversions there. So if we run this again, we should see Wolford Jack had 35.5 hours. So that's good, and we can just kind of do a sanity check here and see that indeed Jack did have the most number of hours worked. And that makes sense because, Jack's always working on those auto graders. We got to give a shout out to him for always working hard on the auto graders so we can get our homework grades out on time. So with that being said, that's kind of our first task done. So let's say now we're going to do something a little bit more fancy. So I'm going to go ahead and I'm going to comment this stuff out. And what I'll do is I'm actually going to keep this. I'll get rid of it. So that's good. Let's go back here now and see what we're working with. So the next thing we're going to do is we're going to try to find the average of all of these hours worked between all these employees. So we can go back in here and we can actually use a good bit of this code again. But I'm actually going to retype it just for the sake of learning stuff. So my file equals, and again we're going to open up employee data.csv. Again, you do need that extension. And just for the sake of seeing the difference between opening it for read and not opening for read, which really isn't a difference when you don't provide an argument, we're going to open it for read this time. Again, we're going to myfile.readline to exclude that header. And for this problem, I'm going to work a little bit faster now that we have kind of a basis on CSVs. So let's get straight into this. So now we've read past the header, so now we're actually into the meat of the data. And now we're going to do line list equals myfile dot read lines. Okay, good. So now we have our line list, and let's just print that out. Okay, good. And let's see what we're working with. And again, we're working with the same stuff, same data. Good. So we're going to use kind of the same recipe as before. We're going to say for I in range length of line list. We're going to do the same thing as before. Line list at I equals line list at I dot split dot strip, excuse me, because we want to get rid of that white space first, and we want to split it on the commas. Okay, good. So now we're going to change this line list to be something more useful and pretty. So let's look at that. Perfect. This is exactly what we're expecting. So now we want to average. We want to see what the average number of hours worked between all of the employees was. So we're going to go in here and we're going to keep track of a sum. We're going to call this cur sum equals 0 and count equals 0. So we're just going to keep these two variables so that we can calculate an average. And we're just going to, again, do for a list in line list, because again, we have sublists in here nested inside of this big list. We're going to iterate over this, and we're basically just going to add up all of these values, all of the hours worked, and divide by the total to get an average. So we're going to say for a list and line list, and we're going to say cur sum plus equals, and again, we have to make sure that we convert this to a float. We're going to say float of a list at 2, because we want to get this value here, which is the second index, 0, 1, 2. So we're going to add up the hours, and we're going to also increment our count so that we can calculate an accurate average. So that's good. And then what we're going to do is we're just going to simply print that out. So we're going to print out, and we're going to print out cur sum divided by count. Because if we know that we have our sum and we have the total number of things we added up, we're going to get an average. So we can go ahead and run this. Looks like I spelled something wrong. A-lit. Okay, good. So now, perfect. Now we get this kind of weird looking value. We should have rounded it, but that's fine. But so we can see that we did what we wanted to do. We can go do a sanity check. Does it look like our average is around 14? Yeah, we have Jack, who worked a lot. We have Tony, who looked like he didn't work at all. Maybe he was slacking off that week. But it looks like our average is around 14-ish, so that makes sense. So that's good. Okay, so that's kind of an introduction to CSVs, using a pretty simple data set. But I wanted to give you guys some exposure to something a little bit more fancy and a little bit maybe more realistic of what you see in the real world. So I have a file that I got offline, and we can actually go ahead and look at it now. So we're going to get rid of employee data for now. We're going to go over here. So now I can show you in my Finder that I have this other population zip.csv and inside the same directory, which is important. And going back here real quick, just one more thing to note. This is like a very common pitfall, and I just made the mistake myself. In this case, it didn't really make a difference because we're just reading from the file, but we like to get all the students in the habit of closing files. So right here, after this, we could have actually closed our file, and that would have been the safest operation to do, just in case something weird was supposed to happen. But since we were just reading, it didn't make a difference. But it is important to always close your files because this can often cause issues. So I'm going to close our file there because we got all the data out that we wanted. And same thing, we could have done it down here right after this line. So again, it didn't really make that big of it didn't make a difference at all for this example. But again, it's still important to do, and I actually made the mistake myself. So keep that in mind. But going back to what I was saying, we'll scoot down past this stuff. Okay. And actually, I just deleted it all. Okay, there we go. So let's go back and let's look at what we're working with. So we have this population zip, and basically this is just a not huge file by any means, but it's a lot bigger than the other one. Let's see what we're working with. We have 319 rows, so pretty big file relative to the other one especially. So if we go back here, let's go back to the top, we can just look at what we're working with. So we have zip code, total population, median age, total males, total females, total households, average household size. Okay, cool. So let's say that you're working, okay? You're working at a job over the summer, whatever, you're an intern, and you know, you're from Georgia Tech, so you probably finish all your work really fast, and so your boss is like, hey, I got a task for you. So your boss is, unfortunately, he's having some issues, and he's gonna move. So he gives you this file, and he's like, okay, it has a bunch of stuff like possible locations I'm gonna move to. So he's like, I know you finished your work, so I'm just basically give you some busy work. So he's like, do you know how to work with CSV files? You're like, as a matter of fact, I do, because I took CS 1301. So he gives you this, and he's like, all right, Jacob, this is what I want you to do. I got some stipulations and kind of some requirements that I want on the new city that I moved to. So what he says is he's like, let's go back over here and write down what I'm going to say. So he wants you to find basically a zip code, because these are zip codes, but basically a city, right? And his requirements are that the median age is less than 35. Okay. The average household, can't spell, household size less than 2. And he said his most important stipulation / requirement is that there are more females than males. Because he said that he's trying to find a wife and settle down in this city. So he wants to make sure there's more females than males so he has a good chance of finding a girl. Okay, so cool. So this sounds kind of interesting. So let's go back and see how we can work with this. So median age less than 35, average household less than 2, more females than males. So this is going to be pretty simple. Obviously we have a lot more going on, a lot more data, so our file or script might run a little bit slower, but it's still all good. So let's go back over here and let's get into this. So let's write a function this time, and we're going to say def city list. And basically what he wants you to do is he wants you to look at this file and he wants you to return a list of all of the possible cities that meet this requirement. So we're just going to write a function named city list that takes in a file name. And this kind of like doesn't matter for this function because, or for this particular instance, because the file name is always going to be the same. But let's just go with this because sometimes you're going to have to pass a file name as a parameter. So again, we can say my file equals file name, open of file name. And again, we don't have to provide a read as our second argument because it's going to default to opening as read mode. So we're going to open up our file, and what do we want to do? We're going to do kind of the same recipe as before. So first we want to ignore those first headers. So we want to say my file dot read line. Okay, good. And so now we've ignored the headers, and then we're going to say line list equals my file dot read lines. And one thing I'd like to point out is this is kind of the recipe and format that I use, where I ignore one line and then do this iteration over the line to reassign values of the list to be individual lists. But there are other ways to do that, so just keep that in mind if this doesn't make the most sense. But for me, this makes the most sense, so we're going to go with this. So we're going to say for I in range, length of line list. Okay, good. So same thing, we're going to say line list at I, and we're going to strip it again because as we can see, actually before we do this, I'm actually going to print out our line list so we can see what we have, and we actually need to call this the city, and what's the name, population zip. Good. Okay, so like I said, this is a lot bigger of a file, so it's kind of nasty looking, but we can see, we'll just go to the bottom and see what we're working with. So if we go all the way down to the bottom, we can see that we have a zip code and all the other data we expect. And there's new line characters in all of them except for the last file as well. So again, we want to come over here and kind of do the same operations as before. So I'll go ahead and uncomment all this out. So we want to strip it of the new line character and we want to split it at the comma. I'm forgetting a dot here, but that's good. So now we were to print out this line list down here instead, should get something a little bit cleaner. Not too different, but a little bit. And this is going to be a little hard to grab. There it is. Good. All right, so we'll run that, and like we can, as we said, it's a little bit cleaner. Still kind of wild because we have a lot of data here, but a little bit better to work with. So we have all of our rows of data as individual lists inside of our main list. Okay, so good. So now we have that. So now we can actually start doing the work. So we have these stipulations up here. Median age is less than 35, average household is less than 2, blah, blah, blah. Okay, so what I want to do here is we want to iterate over each individual list. So for a list, inline list, good. So now we want to do these comparisons to make sure that we're meeting the requirements. And so what we're going to do is we're going to have a couple of variables to keep track of these things. So we're going to have median, I'll just keep age equals, and then we're going to say float of, and then so where does the age live at in this? So it's the 0, 1, the second index. Okay, so that's good. So a list at 2, perfect. So we're gonna have an age variable. We're gonna have a household. So let's say household, and then where does the household live at? So it's 0, 1, 2, 3, 4, 5, the fifth index. Or excuse me, we want the household size. So this 0, 1, 2, 3, 4, 5, sixth, perfect. So we want the sixth. So that's a number as well. So we want to do a list at 6, and we want that to be a float. And then for this more females than males, I'm going to keep this as a variable called ratio, and we're just going to say, we're going to look at here and we're going to say, all right, the males live in the 0, 1, 2, 3, the third index, and the females are in the fourth. So we know if the fourth index is greater than the third index, then we want this ratio variable to be true because that ensures that there's more females than males. So we're going to say float of a list at 4, which is the number of females, and then float of a list at 3. And there's a couple other ways to do this. I just want to do this because this is safe from having any divide by zero errors. But you could do this another way as well. But so this is going to return a Boolean that's going to say true if there's more females than males, or false if there's more males than females. So that's good. So now we're just going to have a simple conditional that's incorporating all these variables. Say if age is less than 35, because that's this stipulation right here, right? And we want the household less than 2. So and household less than 2 and ratio. Since ratio is a boolean, we can actually just put this in explicitly because this will just be evaluated directly. So let's just clean this up a little bit so it's easier to read. And so now if age is less than 35 and household is less than 2 in ratio, so that's going to be, if that happens, that we want to keep track of this this particular city or zip code. So we're actually going to create a variable return list. So we'll say city list. I'm going to say just an empty list. And then so if this holds, then we know that we want to append dot append. What do we want to append? Let's just append the entire list so we have access to all of its data. And then so that's that. If this doesn't hold, we don't want to do anything with that particular city. And then all we want to do at the end is just return our city list. Okay. So if all went well, let's see how this works. We can go back up and call this function again. It's kind of hard to find because we got so much data. There she was. Okay, perfect. So we can go ahead and run this. Okay, perfect. So now we can see our data set, the data we're interested in has gotten a lot smaller, which is good. And this makes sense because we had all these requirements up here to make sure that our city matched that. So now we can see, and this guy's kind of as a sanity check or reality check, we can make sure that all these stipulations hold for a couple of the sets just to make sure. So this age is obviously less than 35, which is good. This household size is less than 2, which is good. And there are more females than males, so perfect. And we can go down here and look at this one as well real quick. Let's do this one. So we can see that the average age is less than 35, perfect. There are more females than males, barely, but yes. And the average household size is less than 2, so perfect. So it looks like our function worked as planned. So we're like, hooray, we did this for our boss, perfect. He's gonna be so happy. So he comes back and he's like, okay, thank you so much, Jacob. But now, all right, you got all these, but we got to narrow it down to one. So now he says, all right, what I want you to do is I want you just to get me the data on the one out of this sublist, so aka everything that's just returned. Out of those ones you just got that met these requirements up here, I just want you to give me the one with the highest population. Okay. So now I'm thinking, all right, this shouldn't be that hard. We kind of already have the bulk of the problem done. But all we need to do now is just figure out which one of these has the highest population, which we know is here as the second entry in the list, aka the first index. Alright, so unfortunately I had some technical difficulties, but I think we're going to try to pick up where we left off, which I think was right around here. So here we go. So where we were was we have this list now that consists of all the zip codes or cities that meet these requirements up here. But now what our boss wanted us to do is narrow it down to one, and specifically the one with the highest population. So given this smaller data now, this will be a pretty easy task. But what we're going to do is we're just going to come down here, is we're going to create a new function called getCity, and it's going to take in a list. And this doesn't necessarily have to be in a different function, but just for the sake of splitting up our code and kind of keeping it as clean and concise as possible, we're going to make this into another function. So it's going to take in a list, and the list is obviously going to be something of this form here, where we have a list of nested lists, and we're basically just going to try to figure out which one of these cities has the highest population and return that list so that our boss can look through all the data in the list. So given this list now, let's go ahead and start writing our function. So we're going to we're going to leave some space up here because I know we're going to have to create some variables, but for now we're just going to start by iterating over our list. So for city in a list, that's going to be grabbing each individual city's information here, so this sublist. What we want to do is, I know that the whole point of this is basically to get the highest population city. So in my head I'm immediately thinking that we should probably sort this list based on population. And so there's a lot of ways to do that in Python with some more fancy functions like lambda functions and stuff like that. But for the sake of this class and the way we're going to teach it for this class is, we know that if you have a list that contains lists or tuples or anything else like that inside of it, that if whatever our first entry is, it's going to be sorted based on that. So currently, if we were to sort this big outer list, it would sort it based on the zip code. And actually it'd be using ASCII values since these are strings, but let's just assume this was like an integer, right? This would just be sorting based on the value of the integer. So I know that, and actually if we think about that, since this is a number that the ASCII value should match up, but that's kind of besides the point. But basically, just the takeaway here is that the first entry in a nested list or nested tuple it'll be sorted based on that first entry. So it'd be sorted on zip code here. So in my head, I think if we had a way to get our population as the first entry and then we sorted this list, that it would work perfectly. So what we're going to do is we're going to do exactly that. And we're just going to do a little swap of the zip code and the population so that our population is at the 0th index of our list. So what we're going to do is we're going to say, okay, population equals city indexed at 1, because we know that for a fact. Then we're going to say city indexed at 1 equals city indexed at 0. So what this is going to do now is it's going to swap the population to be at the 0th index where the zip code used to be. And now what we're going to do is say city at 0 equals population. So I said this backwards. What this did before, the city, this line right here, was that it swapped the first index to now be the zip code. And what this line is doing here is it's swapping the 0th index to now be the population. So now we're iterating over this list, and for each list inside of there, we're swapping the 0th and first index to be the zip code, or to be the population and zip code respectively. So now we print this out, we can see, and we're going to have to do some calling of functions, but a list equals, and we'll call this, good, and then we'll call get city with a list. Okay, look at this, perfect. So if we look how this varies from the one above, we can see that these indexes just got swapped, which is exactly what we want, so that's perfect. So now this becomes pretty trivial, and now all we need to do is, since these are all the populations as the first entry in the list, I know that if I sort this list, which I can do by just going alist.sort, that it's just going to sort based on this first entry, aka the population. So that's perfect. And just kind of an aside, an important thing to remember is this .sort function returns none because it alters the actual list itself. It does an in-place sort. So we don't have to assign a list to be the value of alist.sort, because alist.sort actually sorts a list itself. So just keep that in mind and remember that a lot of list methods do return none. So that's good. So now if we want to go down here and see what we're working with, then let's see, we're going to print out a list. Let's see now what we're working with. Good. Oop. Get rid of that and then do this call. Okay, so this is good. So now we have a sorted list. Perfect. This is exactly what we want. So now we can see this is sorted based on these populations. So we can see down here that this is our highest population, 5464. And so now if we just have a way to access that element in the list, then we can return that and everyone's happy. So we know, since that's always going to be the last element since we sorted this list, that we can simply just say, and I'm just going to do this explicitly all in one line, but you could break this up into multiple if you wanted to. We just want to return a list indexed at a list, the length of a list, right, -1. Because we know that this last index in this list is always going to be the length of the list -1. So that's perfect. That's exactly what we want. So now, if everything went to plan, this should have worked. So let's do these calls again. And perfect. So it looks like this is the list with the population of this, the highest population, and all the other information. And so just to make it more clear and kind of make it more readable for our boss, I guess, just to follow the format of the Excel file, what we can do is we can actually extract this and put it back into the format where it was before, where we had our zip code as the first entry and our population as the second. So just to clean that up, we could do something like this. So final list equals a list at a list, the length of a list, -1. So now we have access to that, and then all we want to do is just say population equals a list at 0, because we know that we did that swap before. So we're going to say a list, or excuse me, I keep wanting to say a list. So this is a list still, but this now should be final list. Final list. There we go. Final list at 0, and then we're going to say final list at 0 equals final list at 1. So that's swapping the zip code to be at the 0th index again. Now all we're going to do is final list at 1 equals population. So all this is doing is just swapping those values back to be of the original form that we see in that Excel file. And then we're going to come down here and we're going to return final list. So if we do these calls again, perfect. So the exact same thing, but all we did here was you just swapped these two values to be these two. So now that's perfect. We get our boss back over and we say, here we go, I got it for you, sir. And he says, great job, thank you so much. And that's a wrap. So that's a little intro into CSVs and kind of working with maybe a bigger data set. So that's really all I have for you guys today. Be sure to leave any comments and email your TAs if you have any questions about this. But I hope you enjoyed the video, and be sure to subscribe and check out all the other content we have. With that being said, have a great night.